Okay, in this video, we're going to be doing Calc Problem Set 64. The problems and the playlists are in the description below. Let's take a look. Evaluate the integral Evaluate the integral of the quantity x minus 1 dx. So we're finding an antiderivative. The answer to this is going to be a function. The answer to this is not going to be a number. So we have to figure out what function basically has a derivative of x minus 1. Think of it that way. That's what you're always doing when you're doing an indefinite integral or an antiderivative. I just called them integrals when I was learning this, and I still kind of do this. We're trying to do the integral of x minus 1. So when you are reversing the power rule, because that's what we need to do, x minus 1, polynomial, derivatives of polynomials, power rule, we're going to always be using this idea that we want to do plus 1 times the reciprocal. So we're going to take the exponent we see, so like x to the first, we're going to add 1 to that to get 2 times the reciprocal of 2. So we'll have 1/2 x squared, for example. So let's actually do that. So it's x to the first, add 1 to that, we get x squared. The reciprocal of 2 is 1/2, so we have 1/2 x squared. Now, where does negative 1 come from? What has a derivative of negative 1? Well, it would just be negative x. Or you can think of what has a slope of negative 1, the line negative x. Or you can think of it as negative 1 times x to the 0, add 1, that's x to the first, the reciprocal of 1 is 1, so you're at the same answer. Do not forget plus c on all of your indefinite integrals, because there could have been any constant there, and the derivative of a constant is 0. So that's your first problem. Let's take a look at the next. So this problem set, I would say, is not like super hard. It's just like little ideas that you have to get used to. One of those ideas is that sometimes when things are written a certain way, you just can't integrate them that way. So for example, this problem, you can't really integrate it the way that it's given. So what I'm going to do is I'm going to expand the integrand. The thing inside the integral is called the integrand. I'm going to expand that. So I'm going to have the integral of the quantity x squared plus x minus 2, and then dx. I like to put parentheses around x squared, the integrand, basically x squared plus x minus 2, because that dx should really go with each of those parts. You do them each separately. You can think of each of them as its own little integral. Integral of x squared, integral of x, integral of negative 2. So that's why I'm putting parentheses around it. It's a good habit to get into. I recommend it. All right, so now we're going to do the thing, right? So we've got x squared plus 1 would be 3. Reciprocal is 1/3, so 1/3 x cubed. And then you can always check that by immediately taking the derivative. The derivative of 1/3 x cubed is x squared, so good. All right, we have x to the first. Add 1, that's 2. Reciprocal is 1/2, so 1/2 x squared. And then we have negative 2x to the 0. Add 1, we get x to the first. Reciprocal is 1, so we just get negative 2x. But then we have to write plus c because any constant could have been there. Its derivative would have been 0. All right, next up, we have the integral of the quantity x to the 3/5 minus x to the 2/3. All right, so what we're going to do here is the same thing. A kind of like, I guess it's a hint. I don't know. Some people are bad at like adding 1 to a fraction. You just have to add the numerator and the denominator. That's going to be the new numerator, right? Because it's like you're adding 5/5 to 3/5. So we do 3 and 5 is 8. So the new exponent will be 8/5. The reciprocal is 5/8. So we're going to have 5/8 x to the 8/5. And then x to the 2/3. Add 1, you get 5/3. The reciprocal is 3/5, so it's going to be minus 3/5 x to the 5/3. I feel like I'm losing my voice. Okay, and then, of course, plus c. All right, let's take a look at another one. So it's like the very first problem we did in this problem set, you just did it. The next one, you had to do a little bit of algebraic stuff, and then you did it. This one, we just did it, but it had rational exponents. Rational exponents are the best thing because if you see like this problem with radicals, step 1, rewrite with rational exponents. You do not want to try to do integrals that have radicals. Bad idea. Rational exponents are the way to go. So I'm going to rewrite this. Our first exponent, it's like the power is the numerator and then the root is the denominator. So it's going to be to the 3/4, and then for the other one, it'll be to the 3/7. So we have the integral of x to the 3/4 plus x to the 3/7 dx. All right, so we're going to add 1 to the numerator. To the numerator? Well, we're going to add 1 to the exponent. Yeah, I don't know, forgot the word there. So we're going to get x to the 7/4. Reciprocal is 4/7, so we will have 4/7 x to the 7/4. Add 1 to the exponent. We're going to get 10/7. The reciprocal is 7/10, so we'll have plus 7/10 x to the 10/7. And then, of course, there could have just been a constant there that was lost when we took the derivative, so we put a plus c. All right, one more problem in this problem set. Find a function such that f prime is equal to 3x minus 2 and f of 1 is equal to 4. This feels really similar to me because I'm trying to find f of x given f prime. It's like I know the derivative and I need to reverse that to get back to the original. So what I'm going to do is what I know how to do. So I'm going to write f of x is equal to, for 3x, I'm going to say it's 3 halves x squared, right? It's 3 times 1/2 x squared is where that came from. And then we'll get a minus 2x. And then we'll have a plus c, because you always have a plus c. But in this case, unlike the previous cases, we actually know enough information to solve for c. So because we know that f of 1 is 4, we're going to say 4 is equal to 3 halves minus 2 plus c. So that would be add 2, you get 6, which is 12 halves. Subtract 3 halves is 9 halves. So c is going to be 9 halves. And then, of course, we want to actually write the answer, right? So f of x is actually 3 halves x squared minus 2x plus 9 halves. That's the entire problem set. I hope this was helpful, and good luck.